In this section, I'm going to teach you how to name ionic compounds. There's several steps in order to get these correct. The first step is to split the formula up into two parts. The first part of an ionic compound is the positive part, or the cation. The second part is the negative part, or the anion. The second step is to write down the first part as normal. For example, sodium chloride, we write down the first part as sodium. We put it just like it is on the periodic table. The third step says to end all monatomic anions in "ide." Notice I didn't say sodium chlorine, I said sodium chloride. So when it's a monatomic anion, meaning one atom and it's negatively charged, we end it in "ide," like chloride. Step 4, name all polyatomic ions with the appropriate ending. Remember that polyatomic ions have sulfate, sulfite, nitrate, nitrite. Make sure it has the correct ending. Step 5, figure out if the first element is a transition metal with more than one charge. If the first element is a transition metal with more than one charge, you must tell its charge in Roman numerals. If you need to review these steps, come back to this part of the video at any time. Let's go through some examples. You'll see here we have CaCl2. It's made up of two parts, the positive part and the negative part. Calcium is the first part, which is our cation. It's the positive. So I write down calcium, and notice I did it as normal. The Cl is the second part. It's called chlorine on the periodic table, but notice it's a monatomic anion, meaning it's only one atom of chlorine. So instead of naming it calcium chlorine, we change that chlorine to chloride. And this name of this formula is calcium chloride. In this next example, we have two parts as well. We've got the positive part, or the copper, so I'm going to write that down like normal. There's copper. The second part is a polyatomic ion, so we're not going to end it in "ide, we're going to end it with its appropriate ending. NO3 is called nitrate. So I'm going to write that down, copper nitrate. But what we need to look at is that copper is a transition metal with more than one charge. So if it is a transition metal with more than one charge, you need to tell its charge using Roman numerals. In order to figure out copper's charge, we're going to use the other part of the compound. Nitrate, or NO3, has a -1 charge. But there's two of them in this compound. So that's going to give us a -2 charge for the nitrates. Well, if this is going to be a neutral compound, then we must have a +2 for the copper. And since there's only one copper to give us that +2, then each copper must be a +2 charge. So I'm going to write copper 2 nitrate. That tells us that the copper has a +2 charge and it's paired up with nitrate. Let's look at the next example. We have two parts again. We have manganese and we have oxygen. Now since oxygen is a monatomic anion, we end it with oxide instead of oxygen. So let's look at manganese. Manganese, if you look on your periodic table, will have more than one charge. Since it has more than one charge, we need to tell its oxidation state. So we look at oxygen. There are 3 oxygens, each having a -2. That gives us a -6 for its anions. Well, in order for it to be a neutral compound, we must have a +6 for its cations. But notice we have 2 manganese that equal that +6. So each manganese must be a +3, so we write out manganese 3 oxide. The last example has silver and chlorine in it. We write it down in its two parts. The positive part is silver, which we write down as normal. And the second part is chlorine, but it's a monatomic anion, so we write it down as chloride. If you look up silver on the periodic table, you'll find out it is a transition metal, but does not have more than one charge. So there is no reason to write out its Roman numeral for its charge. We just write it out as silver chloride.